This is a short lecture about how to name acids. Although most acids are typically covalently bonded, for example, hydrochloric acid, I want to point out, I mentioned this in class, so I want to point it out here too, that although hydrogen lies to the left of the stair step on the periodic table, it is a nonmetal. Hydrogen's just kind of unique and unusual, and people aren't really sure where to put it in the periodic table. But first of all, how can you tell by looking at a chemical formula that you're dealing with an acid? Acids will always have, well, I don't want to say always, 99+% of the time, have hydrogen shown first. That's your red flag that you're dealing with an acid. A couple of properties that are unique to acids that you should be familiar with. Acids have a sour taste. So all the citric fruits, lemon, limes, have citric acid. That's why they taste sour. Soda, especially colas like Coke and Pepsi, put actually phosphoric acid to give them that bite they have. And vinegar, again, is another one. It's acetic acid in that. So acids have a sour taste. They even make candy. The sour gummies and things, they have them coated in acids. Acids are known, probably the most common reaction they undergo is with all sorts of metals. And so they react with metals and form hydrogen gas. There are two types of acids which we're going to be learning how to name. There are binary acids, which contain only two different types of elements. So that would be like HCl, for example. Then there are what we call ternary or oxyacids, which contain three different types of elements. The third element is oxygen, and there are a different set of rules we use for naming oxyacids. We're going to talk about naming binary acids first. They're the easier ones to name. Binary acids, the name of them always begins with the prefix hydro. And the suffix for a binary acid is always IC, ic. And then, of course, as with any acid, you follow up the little name with the word acid. So let's look at some examples of binary acid names. Both of the formulas I've shown you are binary acids. So make sure you're familiar with the definition. Binary acid contains only two different types of elements. I don't talk about how many total atoms, I just talk about the type of elements. So whereas H2S has 3 atoms, it only has 2 different types of elements, hydrogen and sulfur. So it still is a binary acid. So remember the rules where the name always begins with the prefix hydro if it's a binary acid, okay? And then the ending is always ic, IC, okay? So what is this element? It's iodine. So, but instead of writing iodine, we're going to write iodic, and then we're going to end it up with acid. So this is pronounced hydroiodic acid. H2S. We're going to start with hydro because it's binary. This is sulfur, but instead of saying sulfur, we're going to say sulfuric, and then acid. So the name of this is hydrosulfuric acid. The rules for naming a ternary acid, or an acid that has 3 different types of elements, one of them being oxygen, are a little more complicated. So these you may want to take notes on or pay a bit more attention. Oxyacids, first of all, always contain a polyatomic ion, okay? And so there are a bunch of compelling reasons to memorize the names of several of the commonly used polyatomic ions, and this is one of the reasons. But the bottom line is, the rule is, you identify the polyatomic acid that's part of the acid, and if the name of the polyatomic ion ended or had a suffix of ate, when it becomes part of an acid, that suffix changes to IC. So you go from ate to ic. If the polyatomic ion contained in the acid has a name that ended in "ite," then when the polyatomic ion becomes part of the acid, the ending is changed to "us." So it goes from "ite" to "us." And then, as with all acids, write the name acid at the end. So let's name a couple of those, and I have a little kind of memory trick for remembering these rules. So here's my memory trick. It got me through learning this. It is he ate ick and got stomach ite us. Okay, so do you remember the rule? I said that if a polyatomic ion had its name ended in "ate," then in the acid it ends in "ick. And if the polyatomic ion suffix was "ite," in the acid it ended in "us." He ate ick and got stomachitis. Okay, so let's look at a couple of ternary or oxy acids and see if we can figure out the name of them. So let's tackle H3PO4 first. The first thing to kind of drive into is that since they are ternary acids or oxy acids, there is no hydro prefix like there were for binary. Okay, so you just launch in. The first thing you have to do is identify the name of the polyatomic ion. And this one is called phosphate. PO4 is called phosphate. Okay. Now look, my little memory trick or the rules, whatever works better for you. If the polyatomic ended in "ate," the acid must end in "ick." So instead of writing phosphate, we'll write phosphoric acid, and that's the name of it. Let's look at the next one. The polyatomic in this one is ClO4. That is called perchlorate. That's the name of the polyatomic. Again, I should have picked an "ite" one, but it ends in "ate," so the acid name has to end in "ick." So this is called perchloric acid. So to summarize the rules for naming acids, if you have two elements, if it's binary, always use the prefix hydro and have it end in IC. If it is ternary or an oxy acid, no hydro prefix, and you have to remember that he ate ick and got stomachitis. This is simply another summary slide. The last one was pictorial. This is in words, whatever works best for you. I would write one or copy one or the other down as a memory help for yourself. We'll name a couple together here, and then I want to challenge you in the next couple slides to name some on your own. HBr is binary, so we start with hydro and make sure our suffix is ick, hydrobromic acid. H2CO3 is an oxy acid, contains 3 different elements, so there's no prefix. Look up the name of the polyatomic. It happens to be carbonate. When polyatomic ends in "ate," the acid ends in "ick," carbonic acid. And finally, here is another ternary or oxy acid. The name of the polyatomic in this case is sulfite. It ends in ITE, which means the acid ends in us, sulfurous acid. Go ahead and try naming these acids on your own. Oh, look, I just repeated one there. Oh, we just did that one. But pause the video and try to name them on your own, and then we'll go over the names on the next slide. So here they are. Hydroiodic acid, because it's binary. hydrosulfuric acid. This one's a weird one. I point that out because I see it show up in the ACS final and students miss it because you probably already know that H2SO4 is sulfuric acid, and this sounds a lot like sulfuric acid, but it's not because it has a prefix hydro. So that can get tricky. We named this on the last slide sulfurous acid, and I want you to compare these two. Look at the difference between these two. It's just that the polyatomic ion, SO3, is sulfite, so the acid ended in OUS, and the polyatomic ion in H2SO4 is sulfate, so its acid name ends in IC, sulfuric. What about going in the opposite direction? What if you're given a name for an acid and asked to write a formula? Well, the first thing that you want to do is if you see a name has an ending of an acid, you start the formula with an H, okay? If the name has a prefix hydro, then you know it's a binary acid, which you should be happy about. It's easier. If the acid name suffix is ic or ate, that means that you have a polyatomic ion in it. And you need to figure out what the polyatomic ion is. Give these a shot. I would recommend putting the video on pause, seeing if you can write the formulas yourself, and then we will go over them. How did you do? So notice all of the formulas start with H. Okay. The ones that end in us or ic, which is all of them, mean that all of these mean that you have oxyacids. Okay, you have ones with polyatomic ions, and so you have to work backwards. If the acid now ends in OUS, that means the polyatomic ion ended in ite. Okay, so the name of this polyatomic ion, or the formula, it would have been chlorite. So you look up the formula for chlorite in your polyatomic list and you find out it's ClO2 with a minus charge. So there you have your formula, HClO2. Phosphorus acid, same thing, ends in OUS, which means the polyatomic ended in ite. Okay, so the polyatomic you're looking for in this case is phosphite, which if you look up is PO3 with a -3 charge. Now listen very carefully if you're drifting off on me. If the polyatomic has whatever charge the polyatomic has, in this case -3, that's how many hydrogens the acid must have to balance the overall charge of the acid. So remember, the overall charge of any compound is neutral. So if this PO3 has a -3 charge, each hydrogen ion, we haven't really learned this yet, but has a charge of +1. So you need 3 hydrogen ions so that your total positive charge is +3, and it balances out the -3 charge of the phosphite. That's probably the trickiest part of getting formulas for acids correct, is knowing how many hydrogen atoms to add. This nitrous ends in OUS, which means the name of the polyatomic ended in ite. So nitrite, when you look that up, you see it's NO2 with a -1 charge, so you only need 1 hydrogen. And finally, this one's just downright weird because it's not, yeah, you may want to memorize this one. It doesn't follow the rules, so I really don't want to bend your brain cells at this point. But they treat it like a binary acid, even though it's not. It has 3 different elements. But because it's not a oxy acid, they're using the prefix hydro, so you may just want to put that in your pocket to memorize. I won't give it to you on a quiz or test, but the final may have it. That's it for naming acids.